Okay, so in this video, we're going to be looking at more integer programming problems. Specifically, let's look at some examples where we use binary variables, right? So some applications involving 0-1 variables. Much of the modeling flexibility involving integer programming is due to the use of 0-1 variables. In many applications, 0-1 variables provide selections or choices. So 0 and 1, you can think of 0-1 as off and on. You could think of, okay, am I building a new factory or am I not building a new factory? So that's a 1 and 0. So if you build a factory, you're spending money doing it. So that's a 1-0 decision, yes or no decision. So you can use 0 and 1 for that. If there are two choices and you want to pick between two choices, you can do that. The multiple examples of this: capital budgeting, whenever you have fixed costs. So if you're doing something and you incur a fixed cost, well, that's the one way to use that, put that in a mathematical programming problem, is using a 0-1 variable. So we'll look at the capital budgeting and the fixed cost examples. The others are in the textbook. You can take a look at them. All right, so let's look at the capital budgeting example. It says, Ice Cold Refrigerator Company is considered investing in several projects that have varying capital requirements over the next 4 years. Faced with limited capital, management would like to select the most profitable projects. The estimated net present value for each project and the capital requirements are given below. So you're saying that if you invest, there are 4 projects that you can invest in, which is plant expansion, warehouse expansion, buy new machinery, or do new product research, right? So if you decide on going with any one of these, you have these are the costs that you're going to incur for those particular projects over the next 4 years. So if you do plant expansion, the net present value is $90,000. So first year it's going to cost you $15,000. Second year it's going to cost you $20,000. Third year another $20,000, and fourth year it's going to cost you $15,000. A warehouse expansion, again, $10,000, $15,000, $20,000, and $5,000 over the next 4 years. For new machinery, it's going to cost you $10,000 now, and 4 years into the future, it's going to cost you $4,000 probably for some depreciation, things like that. Say a new product research, $15,000 first year, second $10,000, $10,000, and $10,000. And these are the net present values of the project. And this is the total capital that is available to you for those 4 projects. Now, when you say net present value, this is the net present value of what the value is for you. So let's see how we are going to formulate this problem. Now, in this case, it's pretty straightforward. You have 4 projects to pick. You either pick the project or you don't. Those are the only 2 options. Now, if you pick the project, once you're done picking the project, you are going to have those capital requirements over the next 4 years. If you don't pick the project, you don't have those requirements, right? So your decision variables in this case are whether or not you pick those projects. So we say that we have 4 variables: P, W, M, and R. P for plant expansion, W for warehouse expansion, M for buying new machinery, and R for new project research. And these are 4 binary variables. P will be 1 if you choose the project, 0 if you don't choose the project. The same goes for W, M, and R. These variables will be 1 if the project is chosen, 0 if the project is not chosen, right? In the capital budgeting problem, the company's objective is to maximize the net present value of the capital budgeting projects. So these net present values are the net present values of profits that you can expect over the next 4 to 5 years. So the objective is to maximize the total profit that you earn. So it'll be 90,000 times P plus 40,000 times W plus 10,000 times M plus 30,000 times R, right? So those are the 4 decision variables. Again, remember, these 4 decision variables are just zeros and ones. There's zeros if you don't pick the projects, 1 if you pick the projects. So some of these could be zeros, some of these could be ones. And we'll see where we end up. Now, the constraints are how much money you have available over the next 4 years. So if you look at that, you'll notice that you have a budget of 40,000, 50,000, 40,000, and 35,000 for the next 4 years. And these are the costs. And you can obviously not do everything in every year. So let's see. So you do 15,000 times P plus 10,000 times W plus 10,000 times M plus 15,000 times R. This is the total amount of money that you will spend on all the 4 projects. and this has to be less than or equal to 40. Now remember, you will only spend this money if these variables are ones. If the variables are zeros, it means that you will not spend any money. And remember, we are making the decision right at the beginning, right? So the P, W, M, and R being, whether you're picking them or not, you're making the decision right now. And the repercussions will happen over the next 4 years. Okay. For year 2, so if you look at year 2, there's no cost incurred from new machinery. There's only cost from plant expansion, warehouse expansion, and new product research, and so on. So these are the costs that you're going to incur. So 20,000, 15,000, 10,000 for research. It has to be less than 50,000 that's available. 20,000 for warehouse, 10,000 for research, less than 40,000 available. 15,000 for product, 5,000 for warehouse, for the plant expansion, 5,000 for warehouse expansion, 4,000 for the machinery, and 10,000 for research. Has to be less than 35,000 for the money that's available, right? So let's put this into the solver and solve it. So this was, what is this called? Eastbourne Realty. Okay. Okay. Let's do the capital budgeting problem. Okay, so our decision variables are plant expansion, warehouse expansion, new machinery, and research, new product research. Left hand side, right hand side. Let's have that. Decision variables. So these are our decision variables, which in this case are all going to be zeros and ones. Remember that, and we'll tell Excel that. The objective is to maximize the net present value. Again, I'm not going to do everything in thousands. I'm just going to put in the actual numbers, right? Okay, 90,000, 40,000, 10,000, and 37,000. Okay. Let's write these constraints for the next 4 years. So year 1 budget. So the constraints are the 4 years. I know it's weird I'm doing at the end because I just want to look at the numbers. All right. 15,000, 10,000. 10,000 and 50,000. This has to be less than or equal to 40,000, right? Year 2, 20,000, 15,000, 0, and 10,000 has to be less than or equal to 50,000. 30, 20,000, 1,000, 10,000, less than or equal to 40,000. Year 4, 15,000, 5,000, 4,000, and 10,000 have to be less than or equal to 35,000. There you go. Right? So these are the 4 constraints. Now that the data is in, let's write the decision variables, objective function. So let's write the sum product function. So this is the decision variables. These are the objective coefficients. Copy all of that down. So this is where our final solution is final problem is. That's our objective, right? So let's put this into the solver. Again, it's it's maximization of net present value of the project. So that's what we have. Maximum. The changing variable cells. So these are the 4 decision variables that we have. Let's first write the less than or equal to constraint. Oh, let me fix this. They're all less than or equal. There's no greater than or equal to constraint here. So let me add the 4 less than or equal to constraints first. Less than or equal to these 4 values. Oops. Take that again. Okay, I'm going to click on add, and then of course my 4 decision variables have to be binary variables only, right? I mean, if you look at it, there's 2 options here, 2 options here, 2 options here, 2 options here. So in total there are 16 options. So again, if need be, you can just list the 16 options and then figure out which work based upon whether they satisfy the constraints or not. So it's much easier doing it here. So my objective is to maximize my net present value of profit, B2 to E2 my decision variables, which are all binary, and these are my 4 budget constraints. So now here, changing it to LP or not doesn't make sense because obviously it's an integer programming problem, but I like to change it to an LP anyway. It's not going to matter. You can keep it as GRG nonlinear, you'll end up with the same answer. Don't write binary. So if you do binary and you still end up with these numbers, what you have to do is you click on those options. One of the options is ignore integer constraints. Uncheck that. You don't want to ignore integer constraints. You want the integer constraints to be valid. There you go. That's my final answer with my integer constraints, saying that invest in the plant expansion, warehouse expansion, and machinery. You're not going to invest in research. And the maximum expected value that you can get is 140,000 based upon these numbers. You cannot get a number greater than that, right? If I remember correctly, that's the answer. P is 1, W is 1, M is 1, R is 0, and that's how much you have. Now, if you look at the budgets, you'll notice that you're not using up all the budget in the first 2 years or in the 3rd year, but you're hitting the maximum budget in year 3. And this is where the bottleneck is. If some way we could increase the budget in year 3, maybe you'll be able to do all 4 projects. But because there are about $5,000 remaining in the first year, 15,000 in the second year, about 9,000 in the 3rd year. So you can almost, if you can get $1,000 here, you can cover that. You can already cover everything in year 2. In year 1, you have 5,000, you need an extra 10,000 here. And in year 3, you're hitting the budget, limit, which means that you need another 10,000. So you need 10,000 in year 1, 10,000 in year 3, and $1,000 in year 4. And you will be able to do all 4 projects. But that's what we have here. And this is the capital budgeting example. So again, this took 15 minutes. So I'm going to stop it here. I will do the other example in the synchronous session. But this is how so we looked at one example where decision variables were just regular integers. We looked at another example where decision variables were binary. And in the synchronous session, I'll do a couple more examples. All right, take care.